We buy modern, energy-efficient devices to save power, but the very technology designed to lower your electric bill is actually polluting the electrical grid. These devices push a parasitic form of energy backward through the wall, causing massive public infrastructure miles away to vibrate and overheat. To resolve this invisible crisis, a phenomenon electrical engineers call power system harmonics, we have to look deep inside the physical shape of electricity itself. By design, the North American power grid operates on a smooth, rhythmic pulse, a fundamental frequency of 60 Hz. Legacy appliances, like older incandescent bulbs and traditional refrigerators, drew power in perfect sync with that natural rolling wave. But modern electronics, from smart household tech to sprawling commercial server racks, don't operate that way. In engineering terms, these are classified as nonlinear loads. The exact hardware we engineered to save energy inside our homes is creating a heavy, destructive burden on the macro grid outside. Take a simple household light dimmer. It doesn't dimmable by smoothly lowering the pressure of the electricity. Instead, it uses internal electronic switches, components like triacs or transistors, that rapidly chop the incoming power on and off, dozens of times a second. As the switch chops the flow, it destroys that smooth 60 Hz pulse, leaving violent, jagged spikes. Drawing current in sudden bursts rather than a continuous flow ruins the straight line. This is exactly what makes it a nonlinear load. Chopping the wave achieves precise control and local energy efficiency, but it physically breaks the structural integrity of the electrical current. To decode the damage caused by these jagged waveforms, electrical engineers rely on a mathematical tool called Fourier analysis. The math proves that a distorted wave is actually a stack of multiple higher-frequency pure sine waves riding on top of the base pulse. This chart isolates those frequencies. You see the fundamental wave alongside the third, fifth, and seventh harmonics, unwanted frequencies injected backward into the grid. Summed together, they form the green resultant wave, representing the actual polluted current now flowing. Engineers measure this using total harmonic distortion, or THD. It calculates the exact ratio of this junk harmonic energy compared to the clean fundamental power. Ultimately, THD is the definitive metric for how much electrical garbage a single device pumps into public infrastructure. This harmonic power is entirely parasitic. It performs zero useful work for the consumer. Instead, these high-frequency currents travel backward and collide with the physical resistance of the grid wiring. This collision triggers the skin effect. Standard 60 Hz current flows evenly through an entire wire, but high-frequency harmonics are magnetically forced to the extreme outer edges. Crowding into that tiny outer sliver exponentially increases resistance, generating dangerous physical heat. This internal heating is so intense that utility companies must preemptively derate modern equipment, preventing massive transformers like the one pictured from melting down. To survive the harmonic distortion, engineers must often cap their safe operation at just 80% of their true rated capacity. The mathematical abstraction of a distorted wave directly translates into melting metal and massive efficiency losses for the entire grid. We sacrifice the simple, clean power of the past for the highly controllable electronics of today. Harmonic power is the invisible ghost haunting that digital age, forcing utilities to spend heavily on massive industrial active filters just to keep the lights on. Every time you run a smart appliance, you aren't just pulling electricity in. You're sending ripples of distortion backward to the power plant. To see exactly how engineers use those active filters to fight THD, hit subscribe. And let us know in the comments, have you ever walked past a power pole and heard the transformer humming?